You ever wonder what really happens inside that box on your desk? I mean, really think about it? Well, today, we're going to go on a little journey. We're going to dust off a computer guide from back in 2007 and use it as our map to uncover the magic that happens from the very moment you hit that power button.
I mean, think about it for a second. It feels totally instantaneous, right? You press a button and boom, a whole universe of information just appears. But here's the thing. Between that single click and your desktop finally loading, there's this incredibly complex, carefully choreographed dance of technology that's happening behind the scenes.
All right, so let's start our journey right at the beginning. The first step, waking up the machine. You can kind of think of it like a morning routine, you know? Before your computer can help you with your day, it has to get itself ready.
And this wake-up routine, it's super logical when you break it down. First, of course, a jolt of power flows through everything. Then, this really crucial piece of software called the BIOS, that's the basic input-output system, it wakes up. Its very first job is to run what's called a power-on self-test, or POST. It's basically checking in on everyone, asking things like, hey, is the keyboard connected? Is the monitor on? Once it gets a yes to all its questions, it gives the green light to load the main event, your operating system. And that's what finally brings that familiar desktop to your screen.
Okay, so the machine is awake. It's ready to go. But what part is actually doing the thinking? Well, now we're going to meet the core components that process every single command you give. We're diving into the computer's mind. Right at the heart of it all, you've got this, the CPU, or the Central Processing Unit. And look, it's been called the brain of the computer for decades. And honestly, it's for a really good reason. Pretty much every calculation, every single instruction, it all flows through this one tiny, incredibly powerful chip. But what's interesting is that this brain really has two very distinct halves that have to work together. So these two halves, they have totally different but equally important jobs. First, you've got the ALU. That's the Arithmetic and Logic Unit. You can just think of it as the calculator. It's the mathematician, handling all the number crunching and logical comparisons. Then you have the Control Unit. The Control Unit is more like the orchestra conductor. It doesn't play any instruments, or in this case, do any math, but it directs all the other parts of the computer, telling them exactly when to act and what data to use.
But of course, a brain isn't much good without memory, right? And a computer has two main types. First, there's RAM, Random Access Memory. The best way to think of RAM is like your physical desk. It's where you put everything you're currently working on. It's super fast to grab stuff from, but when you turn the power off, that desk gets completely cleared. Then you have the hard disk. That's more like your permanent library or your filing cabinet. It's where you store everything for the long haul, your photos, your documents, all your applications. It might be a little slower to access, but it's permanent. And to really put storage into perspective, let's take a trip back to our guides era, 2007. Remember the floppy disk? A standard one held just 1.44 megabytes. I mean, today you could barely fit a single high-quality photo on one of those things. Now a DVD from that same time? It could hold 4.7 gigabytes. That is over 3,000 times more information. It's just a perfect little snapshot of how our hunger for digital storage has absolutely exploded. Okay, so we've got the physical parts, and we've got the concept of memory. But how do we actually bridge the gap between us, the humans, and this incredible thinking machine? Well, that's where the classic duo of hardware and software comes in.
Now, the distinction here is really simple, but it's absolutely crucial. Hardware is all the physical stuff you can actually touch. You know, the keyboard, the monitor, the CPU chip itself. It's the body of the machine. Software, on the other hand, is the set of instructions that tells the hardware what to do. It's the soul. You can't touch it, but let me tell you, without it, all that hardware is just a very expensive paperweight.
So, to get our instructions into the machine, we use what are called input devices. These are basically our primary tools for communication. The keyboard and the mouse are the obvious ones, of course, but other things, like a microphone for your voice or a webcam for video, those are also input devices. They're all just different ways of feeding data into the computer so it can process it. Now, the single most important piece of software on any computer is the operating system, the OS. The OS is like the master manager or maybe the main translator. It's the thing that coordinates all the hardware and all the other software, making sure they play nicely together. And, crucially, it gives us the graphical user interface, the GUI. That's all the icons, windows, and menus that make computers so easy to use. I mean, without it, we'd all still be typing these cryptic commands into a blinking black screen. No thanks. So, now we've got a working computer with an operating system. At this point, it's a general-purpose machine.
So how do we turn it into a specific tool for pretty much any task you can imagine? The answer is with application software.
Application software is really just any program that's designed to do a specific job for you, the user. So if you need to write a letter, you fire up a word processor. If you need to manage a budget, you open a spreadsheet. Each app basically turns the computer into a specialized tool for that one purpose.
And here's a super simple but perfect example of the power of software. In something like Microsoft Word, right, you can type a sentence, and then with a single click, you can instantly change its case from lowercase to uppercase to whatever. Now, just for a second, imagine having to do that manually for an entire book. That right there is the magic of software. It automates these complex, tedious tasks and saves us an absolutely incredible amount of time.
Okay, so after the computer has done all its processing based on our commands, we need to actually see the results, right? This is called output, and it really comes in two main forms. You've got the soft copy, which is just what you see on your monitor. It's digital, it's temporary. And then you have the hard copy, which is what comes out of a printer, a permanent physical copy that you can actually hold in your hands.
But let's be real, especially since 2007, a computer is so much more than just a standalone machine. It's our window to this vast interconnected world. So for the final leg of our journey today, let's take a look at how our little desktop actually connects to the internet.
So what is the internet anyway? At its very core, it's just a massive, global network of networks. That's really it. It's millions of computers all over the world that have agreed on a way to talk to each other. Now, the part that we usually interact with is the World Wide Web. That's the huge collection of websites and web pages that are stored on all those connected computers.
And the path your request takes to get a web page is pretty amazing when you think about it. So, you type an address into a browser, your Chrome, your Firefox, whatever. That request gets turned into a signal by your modem and then sent to your internet service provider, your ISP. Your ISP then acts like your personal gateway to the entire internet, zipping out there to find the exact computer where that website is stored and then pulling all that data right back to your screen. And it all happens in, what, a fraction of a second? It's incredible.
Have you ever really looked closely at a web address and wondered what all those bits and pieces mean? Well, each part has a specific job. The HTTP part, that's the protocol, which is just the set of rules for the conversation between the computers. The www tells us it's on the World Wide Web. Then you got the unique domain name, the example part, and finally the top-level domain, like .com for commercial, .edu for education, or .gov for government. It's like a full mailing address, but for the internet.
And there you have it, from a simple button press all the way to a global network. That's the journey. You know, the really amazing thing is that these fundamental principles, even from a 2007 guide, are still the foundation of how computers work today. Yeah, sure, the parts are way smaller and unbelievably faster, but that core logic, input, processing, storage, and output, that all remains the same. So it leaves us with a pretty big question, right? As we race into an age of AI and quantum computing, what parts of this journey are going to change next? And what parts will always stay the same?